I'm Tim Ventura, and we're joined today by Robert Quinn, a semiconductor engineer, STEM advocate, and computing subject matter expert with over 25 years' experience in information technology. Robert has a BS in Management Information Systems and career experience with Samsung, Retronix, Applied Materials, and ECS, among others. His past clients include IBM, Intel, BAE Systems, Global Foundries, Texas Instruments, Freescale Semiconductor, and many more. Today, Robert works as a thought leader, podcaster, author, and content curator, helping to educate others about the latest trends and technologies in computing and IT. Okay, so Robert, welcome, sir. Welcome.
Thank you. I appreciate it. It's good seeing you. There's so much growth in the industry that's gone on this year. It's incredible. We've I think they've said close to $400 billion of growth investment in the last 2 years. It's just
That's
it's
now
just
is some of this bringing the chips back home, right? Because I know that was an initiative. So,
oh yeah, I sit on a board actually with a group of an analyst, and one of the CEOs of a big company said, yeah, he said he said technology is the great equalizer. He said technology he says he's shutting down his fab in Shanghai and he's bringing it home to Ohio. And he says he's doing it cheaper than he's going to be able to do it in Shanghai because of automation. So,
well, yeah, I mean, so you and I are both on LinkedIn, right? And we're both in a lot of groups. And one of the things that I've seen is post after post after post saying our supply chains, our technology supply chains are so vulnerable, So part of it is bringing that stuff back home. That gives us economic security. It also gives us jobs. I mean, it helps build back up the economy, and so
we have to bring it back home and do a lot more, but at the same time we have to also realize that this is a very interconnected system. If you look at your cell phone, there's probably like 30 countries involved in the making of your cell phone. It's incredible. Like, I mean, from the rare earths that are collected from China to the fabrication of different parts in Vietnam, and the manufacturing of the chips in Taiwan, and the cutting and testing and all that stuff done in like different places like Korea, and different optics that are made in Europe, and just so much of it is so interconnected throughout the whole world. It's incredible. Like that, you look at your phone and you just can't imagine the infrastructure that it takes to be able to make that cell phone. It's incredible.
yeah,
So
yeah. No, those chips, they go everywhere. They literally go everywhere. In fact, I just saw a report. This isn't cell phones, but I saw a report about crashed Russian missiles, I believe. I think it was 2 of their new missiles, and they said they had 31 components in them from American companies. And the
wow.
American company said, we have no idea how they got those components, right? And that's not surprising. I mean, and odds are they probably just purchased them like any other company and said, look, we need this part to make this board. And, it happens to be going into a missile. But yeah, I mean, these things they do. It's a global industry. So in terms of bringing it home, then, like for this fellow that you were talking about, bringing it home from overseas back to Ohio, are there challenges there? I mean, he has to get the tooling, he has to train the people, they have to create the clean rooms, they have to do all that stuff, right?
Yeah, I mean, we have to do a lot. And it's not just the fab. That particular guy, he's going to be building another fab in Ohio, and he's doing RFID. But yeah, I mean, he has a lot of work to do, and but a lot of automation to bring in, and it'll be challenging, but at the same time he's done the math, and it's going to add up to being profit in his pocket. It's going to be profitable for him to actually bring it home, so it's good.
Yeah. Well, and I think that there's a synergy there too. And the reason I say that is, I mean, these chips were developed here. The advances are done for the most part here, right? I mean, not all the not in every case. You know, like Samsung is doing amazing things and they're based in Asia, but you know, but still there's a ton of American innovation that can happen and does happen. And I would bet you that when you bring those home and he's able to actually walk down to the fab and talk to the people who are building them, that you're going to see, you know, large jumps forward as opposed to trying to send it overseas and then wait months to be able to test something, you know.
Yeah, yeah, and you know the technology is just evolving at such a rapid pace right now. Did you hear about the new Cerebras chip that just came out?
No, no, can you tell me about that?
It's like 850,000 cores, 2.6 trillion transistors, 2 petaflops of data. Like it's incredible. It's incredible. Like I mean, like it's in the new AI chip. I think Dojo's using it for the Tesla Dojo, the AI that they're doing. Like I think they're going to be using that Cerebras chip. But
Yeah,
yeah, it's the amount of the speed that technology is moving at, and people don't realize it's here.
yeah,
um
yeah. One of the things that I've been following is what's been going on. I did some reading up on Intel, and I've also been doing reading on where ARM is going, and they're both really exciting. So Intel right now they're on a 10 nanometer process. They call it the 7 nanometer, I believe, but it's actually 10 nanometer enhanced. From what I understand, the furthest down you can go is 1.4 nanometers, and
right.
Samsung is actually working on that. And so past that point, you're literally trying to send current through a single atom, which is crazy, right? I mean, so they're getting close. And in fact, let me read through some of my stats here. The new Intel chip, this is when I was doing my research, 12th generation Gen Core i9 12900KS. It has 16 cores, DDR5 RAM, which is twice as fast as DDR4, right? The RAM that most folks are used to. And it peaks out with the turbo boost at a remarkable 5.5 gigahertz. So this is a chip that people right now, people can go out and buy this, put this in their PC, and then the question becomes, who needs a chip that fast? Probably only gamers at this point, but so again, 10 nanometer enhanced process. Now, by 2024, that's only 2 years away. They think that they're going to get down to this 2 nanometer process. It's called the Intel 20A process. And again, 1.4, I think, is as low as you can go, So I don't know. From a semiconductor perspective, I mean, how do you think things will change when they hit that? I mean, and the reason I ask is that they've been relying in large part on, okay, we'll make the transistor smaller, they'll be more energy efficient, they'll run faster. I mean,
Mhm.
they'll have to change the game, right?
Obviously the transist, we obviously we get smaller gates, and we go, keep going down and keep following Moore's law. And then of course once you get as that happens, we'll also start seeing things happening like packaging, is where packaging chips, we're going to start seeing chip stacking, where they're stacking chips and within packages, or they're doing 2D 3D packaging. It's going to be there's a lot of different ways they're going to be able to approach this, through architecture and packaging, and they'll continue to increase speed through also different types of chips. I don't know if you're familiar with the new power chips that are coming out. Wolfspeed's going really big into the silicon carbide industry. Silicon carbide is it's a substrate, just like silicon is, that is a semiconductor, that can withstand higher temperatures. And so I guess silicon carbide is the next best thing, and then I guess after that, the next best thing would be diamond, which they can actually do. But yeah, it's interesting watching the technology change. and seeing how it's moving forward.
Okay, so with these higher temperature chips, then basically, I mean, because the enemy of transistors is heat, right? Especially when you get them into these packages. Now, again, I did a lot of research for this. One of the things that I found 20 years ago, IBM produced a 1 terahertz transistor. And like, I believe there are transistors that may even be faster than that now. But so the transistor itself can do it. The problem is keeping it cool. And when you put billions of these things next to each other, right, you run into these heat issues. I mean, so you think they can just keep making the speed faster and faster if they go to these power chips, or?
They'll make them faster and faster, and there'll be different technologies that will make them more powerful. I think also another thing that's going to come into play in the near future will be artificial intelligence. We're going to be using a lot of AI to develop architecture and to using artificial intelligence to be able to design do design as well. So yeah, it's not just the chips themselves, but it's the the packaging of it, the design of it, and the architecture and how it's designed, and all that will be changing throughout the years, and we'll see that evolve as it continues to go.
Yeah, yeah. Well, and again, I won't dig in too deep into my research notes. I'm just throwing out some tidbits here. I spent a lot of time kind of catching up on this. Now, in my case, I started from the ARM perspective because I probably shouldn't admit it in public, but I'm a Mac user, right? And Mac has taken everything ARM based. And in an interesting way, they have kind of a different strategy than Intel. I mean, when I was reading up on Intel they're still pushing for horsepower, and I mean it's just faster RAM, smaller transistors, the whole thing just gets faster and faster and faster. In Apple's case, if I understand correctly, like I'm on this new Mac Studio, you know, box that sits on your table. And if I remember correctly, it's only about 1.7 gigahertz for each processor, right? That's not that fast. I mean, Intel, they're over 3 gigahertz clock rate for all of them. But
Mhm.
what makes it different is the memory is on the chip. It's all SoC. And so you have these really high, I think it was like 400 gigabits per second. So they're able to move data around between these processors. And then they're using this parallel array. In my case, I think it's 20 different little CPUs. And you mentioned, right, the Cerebrus a few moments ago, where they just keep making them more and more and more. It's massively multi-parallel. So
Yeah, it's amazing how the growth of the industry and how it's catching up to us. Like, I mean, people are just completely unaware of the speed that the technology is coming at us, and I think we're going to see that just go parabolic in the future because the with things like artificial intelligence coming into play. Um, I was reading the other day that we're going to have in the next 5 years, we're going to double the amount of data on this earth. 5 years, and then from there it just goes infinite from there. That's incredible. So yeah, the way that we change the technology and the way that it's going to grow and alter our lives, I think it's going to be amazing.
yeah, it's transformative, I mean, and I don't know. We need these advances to keep up with that data, right? If we double that, I mean, just think about how long it's taken us to reach this point, and then 5 years from there, and it won't stop there. It'll probably just keep increasing and increasing. It may double again the next year after that. And you know, I don't know if you remember back in the 90s, they had this news story about they finally reached the speeds where they could transmit the entire contents of the Bible coast to coast,
Yeah.
in 1 second, right? And you know, right now the Scandinavian researchers just did 1.8 petabytes, which is, if I remember right, it's like 1,000,000 gigabytes or 1,000 gigabytes or something like that in 1 second over an optical connection. So it just keeps increasing, you know.
It does.
Well,
It does.
so from a transistor perspective, from a semiconductor perspective, let me back up a second. What are you most excited about in your industry?
The growth of the industry, it's incredible right now. We're seeing about $400 billion of investment within the last 2 years. Intel's building a fab in Ohio, Samsung's building a fab in Austin, and TSMC is building 2 fabs in Arizona, and so is also building fabs in Arizona. Fabs going up all over the country, all over the world, really. I was just in Munich. I just got back last week from Munich, and seeing more growth in Dresden and around the world as well. The demand for semiconductors will continue. We will continue to see an infinite demand for them because we will be using semiconductors more and more. There's many different reasons why we'll be using them. But I think the growth of the industry is what excites me more than anything right now. There's a few challenges involved in that, as far as how we're going to get the staffing and the people to be able to fill all these fabs. And there's a few things I'm working on with that as well. But yeah, it's the growth of the industry and watching it, watching the investments and seeing how people are getting involved. It's amazing right now.
Yeah, yeah. Well, and it's interesting to see all of these coming to the Texas area also, right? So they're coming to the middle of the country. Now, is there a reason for that? Is it just cost based? I mean, I know it costs less like Texas is a growth area for a lot of things because the costs are lower compared to like California or maybe New York.
Whenever they pick the fabs and where the fabs are going to go, they look at a few things. One of them is water. Obviously, you have to have, like, for instance, Samsung Austin is the largest consumer of water in Central Texas, water and electricity. So these fabs use a lot of electricity, a lot of water. And then they, of course, look at a lot of tax incentives and state incentives that they're, through school districts and whatnot. But yeah, there's a lot of things that they try to use to find out where they're going to put these new fabs. Governors around the nation are trying to fight over getting the next new fab. There's a lot of economic development councils that are reaching out to me and saying that, we're hoping to get the next fab here. And yeah, there's it's a lot of work to try to, I mean, these fabs are 17-20 billion dollars, right? Intel just announced today that who they're going to contract to build their fab, the $20 billion fab in Ohio. And so these projects are incredibly huge. They will take, lots and lots of money to build, an incredible infrastructure of construction workers and construction companies to come together to be able to build all these fabs around the country. And, just putting them all together, I think, and building these fabs will be challenging, but I think we have the ability to do it. So
now, out of curiosity, do you know what happens? I mean, the Asian fabs don't just go away, right? There's TMSC and they've got stuff, I mean, obviously in Taiwan as well as mainland China. Will they transition? I mean, are they going to basically make the same products for the Asian market, or will they end up transitioning to different types of semiconductors if we start bringing home, some of the mission critical stuff here?
I think TSMC is the leader in the world. TSMC is obviously making the most advanced chips in the world right now, and everybody's depending on them to make those chips. I think as they realize that this is a very global industry, they're starting to reach out to they're obviously building their first fab in the United States. And they just announced that they're also going to build a second fab in the United States as well. So we also see Samsung reaching out, building a fab here in Austin, another fab here in the Austin area. and they're also looking at India and other areas of the world as well. And so they're trying to, reach out and become very interconnected around the world. It's amazing. These chips, when I worked at Samsung, these chips were manufactured here in Austin. They were packaged up. They were shipped directly back to Korea. They were tested and packaged and tested, cut, packaged, and all that other back end work was done there. And then the chips are sent off to other parts of the world, of China and Malaysia and all these other places where they're, all the other back end work is done. And it's so interconnected watching, how all this work is done. But there's I think that TSMC has realized that they have a very they're very hinged on their country alone, and that they need to be more interconnected around the world and have more of that. So
yeah. Well, and concerns about Chinese governance, right? That's something that's obviously been in the headlines. Another thing is COVID, right? I think we just never saw boats stop before. Those shipments kept coming until they stopped, and then it was like, well, wait a minute, where's our stuff? And if you're a manufacturer, that's a big problem, right? And that held up supply chains across the country. So I think that inspired a lot of what's going on today, and it's exciting to bring it home too, because, when they build these fabs, right, they're able to use the latest and greatest. So, it again, I think everything will just start to move forward as a result. You're going to have more synergy. You'll have more local connections between designers and test and, an actual production. And they'll be using the latest fabrication equipment. In Intel's case, and again, this goes back to CPUs, they're starting to look at hybrid CPUs. That's an area where they want to be basically, one thing they've talked about is producing CPUs that can apparently run both ARM and x86 instruction sets, if I understand that correctly. I could be mistaken. The other thing they're talking about is starting to produce chips for other companies, right? So maybe Intel will make some of Samsung's chips or something along those lines.
Right. Well, TSMC is already making chips for pretty much everybody, all the manufacturers, Intel, Samsung, so we're going to see more of this probably. And as we're getting, there's a particular technology that made TSMC so successful, and it was called EUV. The EUV technology allows us to go go down to the smaller nodes. We kind of hit a bottleneck. At one point, I remember back in 2016 era, we were looking at this technology going, well, okay, does Moore's law come to an end, at 7 nanometers, or what happens? And so EUV came out, ASML came out with a new tool. This tool is incredible. The amount of technology that goes into this equipment is just amazing. And this allows us to come down to the 1 nanometer node as far as the technology goes. But we'll see. TSMC was the first innovators because you can buy this equipment, right? But it doesn't mean you know how to use it, right? You have to perfect your recipes. So you have to get the equipment. You can buy the oven, doesn't mean you can bake a cake, right? Like, you still have to be able to perfect your recipes. You have to be able to really do a lot of trial and error and research and development into perfecting yields for the equipment. And so TSMC has mastered that. They are the global leaders as far as being able to produce the smallest nodes at the highest yield. And other fabs like the Intel fab in the United States will be an EUV fab. The Samsung fab in Austin Austin area will be an EUV fab as well. So those fabs will get their EUV equipment, and they'll have time that they'll have to actually go in and perfect those recipes and master what they're doing with that equipment.
Yeah. So in terms of EUV, and this is just for the audience, you're talking about basically ultraviolet as opposed to conventional optical lithography, right? So instead of using the visible spectrum, you basically move to UV because the wavelengths are shorter and you're able to do more precise lithography. And then now in terms of node, can you explain what that means? I've been reading that too, and I'm not super familiar with it.
I didn't hear you. I'm sorry, note.
Oh, node. No, we were talking about the 1 nanometer node. Is that just the, would you call that the transistor size, the die size?
That's the gate size.
The gate
The one.
size. Okay.
So I always talk to people about, I teach a few classes about semiconductor and the equipment that we're working on, and I try to bring excitement into the technology, and it can be so boring sometimes, and people they just say, oh, semiconductors, oh no. It's just over my head, but I talk to people and I say, listen, we're working on equipment that pumps down, the vacuum inside this equipment pumps down 10 to the -9 torr. That's deep space vacuum. Then it injects a plasma that's as hot as the surface of the sun. And then we're building trends through different processes like atomic layer deposition and EUV and epitaxial processes. We're able to build transistor gates now at 3 nanometers. That's 21 atoms wide. So to put that into perspective of, to putting it in people's minds of understanding, everybody knows what the sun is, everybody knows what deep space means, deep space vacuum means, and putting that into normal perspective is good, I think. But yeah, that's we're moving atoms. It's incredible. This equipment that we're working on, we're stacking atoms, and with the transistor gates that we're building are they're averaging the 1 nanometer and the 3 nanometer and below is kind of still R&D. 3 nanometers is a goal that they're trying to hit right now, because sure, you can do the technology, but what yield can you perform it at, right?
Yeah.
And if you can only get 3 chips out of a whole wafer, it's useless technology. But if you can get a 90% yield or an 80% yield, that's incredible. So it's definitely profitable at that point.
Well, and if I could pause for a second, and again, this comes back to CPUs, but as I understand things, like Intel has it, I've heard this several times, that when they do a run and they produce a bunch of chips all at once, not all of them pass, obviously. So the ones that pass for certain criteria get packaged up as different processors. And so the ones that pass all of those benchmarks, that's your highest grade, right? That could be like your i9 that we're talking about now. And in this case, we would say, okay, they're all going to be i9s, but if you look, Intel may have 10 or 15 different model numbers. And as I understand things, basically what they'll do is grade them, and they'll say, okay, this one, this isn't a perfect chip, it can't run quite as fast, we'll put it here. Is that kind of
right.
how it works?
Or they'll just scrap it because it's just,
Yes.
it's got a giant particle on it and it's just trash. But yeah, from what I understand, there are different levels of processors and as far as quality goes. But I'm not too familiar with that, but I do know that there are different levels of it. So
Yeah. Well, so you do the Semiconductor Mobile Education Unit, right? I believe it's SIMEU. Can you tell me about that a little bit?
So there's a lot of problems in the semiconductor industry right now. We're expanding. We're almost going to double the size of the semiconductor industry in the next 3 to 5 years. A large portion of the semiconductor industry engineers right now are nearing retirement, and so to top it all off, there is very few people in the pipeline interested in getting into the semiconductor industry. We've kind of done it to ourselves. In the 25 years of being in the industry, my wife and kids have never been to my work because it's so locked down. The intellectual property is so locked down.
They have to get them little bunny suits, right? Little child-sized bunny suits. So
Right. And I walked through 2 metal detectors to get into work, and to leave work, and it's the intellectual property is incredible with these fabs, and the security that's you have to go through, and the background checks that you have to go through to be able to get into them. So we've kind of locked out the world from the semiconductor industry, and it's not been good because a lot of people have no clue what we do. I went to go buy a cell phone the other day, and I was wearing my old Samsung jacket, and the guy looked at me, he goes, "Oh, you work at Samsung?" So yeah, he goes, do you sell cell phones? So no, I work on semiconductor equipment. And he goes, what are semiconductors? So no, we're in trouble. I looked at the girl next to him and I said, do you know what semiconductors are? She goes, what's that? So no, we're in big trouble. So I've seen this coming for a while. Everybody from Washington, D.C., all the way down has been looking at this as a big problem, but I've seen nothing happening as far as, people actually making action. Purdue University is doing something. I see a few universities around the country doing a few things. But as far as exciting the next generation, which is what we have to do, because we have to start working on middle schoolers today and getting, them excited about this industry. And we had
Yeah.
I have started a nonprofit organization called SEMU, Semiconductor Engineer Mobile Education Unit, and the goal is to build a 52-foot semi that will be able to tour, that will expand to 1,000 square feet. The walls pop out and a slide out, and it'll have a climate-controlled space inside with a lot of different activities and things that will excite and the next generation about the semiconductor industry. And bringing this unit to schools and middle schools and high schools and community colleges all around the nation, just to get the next generation excited about the industry. And it's really a three-phase approach. SEMU is kind of the spark, where you give the student the spark. I think Microsoft did a study that said the average STEM graduate was sparked by one thing in his life, and it was that one thing that made him get into following the career path that he did. And so hopefully SEMU can be that one spark in a child's life. And then we'll have to, you follow them throughout their education, and you bring them into fabs, and you partner them with universities and labs and fabs around the country. And so they can come in and they can learn about the semiconductor industry, and they can get educated about semiconductors and why they're important and why they're going to be the next best career to be involved in.
Yeah.
And then you get partner with universities and the scholarship programs, and then you get these kids into schools and you get them educated about semiconductor. And but it's funny because it's not just the scholarship programs. There's there's all kinds of people that we need in this industry. We need logistics people. We need guys from every education level. I mean, we can use anybody. We can use high school graduates. I've seen high school graduates working in fabs before, that are pursuing their degrees. I personally obtained my degree at Applied Materials while I was working, and so you don't have to currently have a degree to get into the industry. And I think that's important for people to know and to learn about the industry and to figure out what is a semiconductor.
No,
Right.
the education is so amazing. It reminds me of, I think people don't always, I think we understand. I don't think that we acknowledge enough the role of, what would you call it? Corporate culture, right? Well, we call it corporate culture, but I read a book. It came out a while ago. It was called The Social Life of Information. It was Harvard Press, I think Brown and DeGood. And at the time, this was really big during the dot-com industry. So, a lot of folks out there have probably read it. They talked about ITT, if I remember right, and they had a problem where they did, this was back in the 70s, they did layoffs in their call center, and it was layoffs related to technical products. And what they found was when they rehired, even after training people, they just couldn't make it work, right? The people didn't know, they weren't able to answer questions, they weren't able to help their customers, they lacked that corporate culture. And so they had this management firm come in, and this is why it ended up as a story in the book. They had tried everything, right? They tried all sorts of education programs, this, that, and the other thing, and it was just too much technical information. It was too far outside of these folks' wheelhouse, And finally, the firm came in, and they had a social psychologist with them, and they went through everything, and they ended up buying longer phone cords for their call center staff, right? And this was back in the days where nothing was wireless, and
Right.
so supposedly one of the executives who said, well, what's that going to do? And they said, well, that the problem is you've got the new guy sitting over here, and you've got the guy next to him, who got still has 20 years of experience in this. And the problem is their cords aren't long enough for them to wheel their chair over and ask questions. So they did that, and it solved their problem in like a couple of months because they were able to take that information that they already knew. It was part of their corporate culture and share it, right? The different people. What you're talking about with semiconductors, it sounds the same way. It's getting people excited and making them part of a community, you know, that
Yeah.
that sounds like a really big thing. So when do you anticipate putting the wheels on the road with this thing?
We need funding. We need funding. I have some very interesting meetings set up with some people that I'm hoping and praying for some really good results from, and will some good partnerships to develop. And I think everywhere I turn, everybody says, this is this is what we need. This is what we have to do. And this is and it's also funny that people keep coming to me and they say, Robert, thank you so much for putting this together, and this is amazing, this is exactly what needs to happen. And they keep saying to me, don't give up, don't give up, don't give up, keep pushing through. And despite the fact that they don't really know the challenges, I really am looking at Mount Everest. I'm standing at the base of Mount Everest looking up, because it is going to take a lot of money and a lot of effort to put it together. But I think it has to happen. It has to happen. We have to make it happen. And I'm excited about it. And I think a lot of other people are as well. So
Yeah. Well, and you're in the central Texas area, right? That's your region. So these companies that are coming there, I mean, again, you mentioned Intel and others putting up fabs. Once they start to put up fabs, once they start to get people in that area, I would bet that, you'll have more interest, more education, potentially more funding, things will, again, that synergy will start to take effect.
yes, yes, definitely, definitely. And the more we're starting to see these fabs are going to take a long time to build.
Mm.
Um, I was reading the other day that the transformers that these fabs use are on something like a 30-month waiting list. Like it's
Oh, okay.
and so maybe they'll get some refurbished ones. I don't know. I don't know what the resolution will be, but there's a lot of infrastructure that goes in behind to making these fabs operational. And I think they say the average EUV tool right now is on a 2 to 3 year waiting list. And so it will take a lot of equipment. Applied Materials, Lam, Tokyo Electron, in ASML, all these companies are just backlogged with orders for all these fabs around the world that are going up. And they just can't build the equipment fast enough. So
Yeah. No,
we'll
it's a good point. I mean, you don't just go out and create a deep space vacuum, right? It takes some special tools, So,
yeah, yeah. And so these we'll make it happen. It'll all come together, and slowly but surely, we may see a couple of pushbacks there. I think 2023 will be a difficult year, probably, for many industries, not just semiconductor, but many industries will see a downturn in 2023. But it'll be a good time to catch up as well, with so much growth in the industry. And then I think 2024, 2025, we'll see just continued more growth in the industry. So
one of the things, and if it's okay for me to throw out some more of my stats from my research project, again, I'm feeling proud. I did a lot of digging here, but a lot of this was stuff that I was following anyways. I just collected a lot of data. One of the things that's interesting is Apple now is claiming, I mean, they have a small percentage of the desktop market, and they always have. They're claiming that 8% of desktop PCs are on ARM chips. And that's something that I've been really excited about because it's so transformative in terms of the industry, right? And again, it's one of those things that I think everyone is they kind of know in the back of their head, they just don't look at it too closely. But so if I understand correctly, in 2021, something like 1.5, I'll have to look it up. Was it 1.5 or 15 billion cell phones shipped? And let me see here. I can't even find the data. Something like 5 times more smartphones shipped every year over the billions than
Yeah.
PCs. So I think it was like 15 something.
Mhm.
And what that means is ARM chips are massively proliferating the market because those are all on ARM, right? And then you've got developers and testers and everyone. They're basically they're very tied to this ARM infrastructure now, and they're trying to support desktops as well. So it shouldn't be a surprise that Apple is basically trying to normalize on a single architecture and saying, look, we don't want to have to support this across two platforms. Um, but what is interesting is, again, Intel's looking at making hybrid chips.
Mhm.
If they make chips for other manufacturers, they may start to support that ecosystem. Microsoft, in terms of software, has Windows on ARM. And so there's a lot of potential transition that could be happening here, right? I mean, there's no guarantee. Intel chips keep getting faster and better in the x86 world, and they definitely serve a need, but then at the same time, there's this massive mobile pressure that's going on, you know. So
The Internet of Things is going to explode in the future. I think they said there's going to be 2 trillion Internet of Things devices by 2035. And that's going to take an incredible infrastructure to be able to make all these devices. And we're going to be so interconnected to the internet and through so many different ways. But yeah, we'll see a lot of growth. I had an interesting interview with Naveed. I don't know if you know who he is. He's the CEO of Rapid Silicon, and they're working with FPGA, open source FPGA. FPGA is essentially a chip that is an open source chip that is the hardware is formed by the software. So imagine that.
oh, okay. Field programmable gate array. That's
Right.
okay. It's been a while.
And, and you can actually create just upload a software package to a chip and then change the physical attributes of the chip. And so it's something that's going to be very useful for Internet of Things devices, and that going forward with that type of technology. There's a lot of new infrastructure we'll see there as well.
Yeah, yeah. Well, and in addition to that, one of the other things that comes out of ARM is this giant move towards system on chip, right, or SoC technology. And again, that's been around forever. I mean, I worked at AT&T Wireless years ago, and that was something they were doing with some of their systems. But the thing that makes it different now is, like in Apple's case, you've got neural networks on a chip, right? They're looking at, again, the Apple Studio, you've got memory on the chip. And from a semiconductor perspective, that means, even if you're making the same chip, all of a sudden the chip becomes different because you have to add all these additional items onto it. Cryptography is another thing that's going onto chips. Um, and who knows? And maybe we'll see quantum computers on chips at some point. I mean, they have chips, IBM does. Maybe they'll start putting them in there with the rest if they can figure out the cooling issues.
Yeah, I'm excited for quantum computing and see where it goes in the future. And I think it'll be the answer to a lot of questions in the future. There's a lot of money being invested into it, and so we'll see where that goes. But there's still a lot of things that they have to solve, a lot of difficult challenges that they have to solve to be able to make quantum computing viable for the industry. So,
Yeah.
but nothing that I think won't be solved. So
Well, the scale also, and I'm no expert on this, but so IBM just unveiled this 433 qubit quantum computer, and I was really excited about that. I thought, wow, that's amazing, right? I mean, that they keep doubling it, right? It's this exponential doubling. Um,
Mhm.
so they keep doubling the number of qubits over just a couple of years ago, and I said, that's tremendous. Well, I've been told that they need something like 50,000 to really start doing usable calculations. So I'm like, okay, might take us a bit to get there, but
Yeah,
still, they're making progress.
yeah, and it's just chiseling away a little bit at a time, and they'll get there. But it will take some more R&D and development to be able to really make it something that's very usable. And
Yeah.
but I can imagine marrying quantum computing with artificial intelligence. I mean, just the thought of that like is just incredible. Like you know, you talk about having sitting in an AI, like, golly,
Well,
what are
that really makes this an amazing time to get into the semiconductor industry too, right? I mean, all of
we're,
these possibilities are out there, you know?
we're just this is just the birth of the industry. This is just the start. And we're it's such an incredible phase right now where how far we can go with the technology in the future, and this is just the start. And so that's what I'm excited about more than anything,
Yeah.
and seeing where it's going to go.
Well, I'll
If
put I want to put your info in so that people can reach out to you too, because I'm a parent. And if my 13-year-old daughter came home from school and said, Dad, I want a career in the semiconductor industry, I would probably start crying tears of joy. Like right there. That's like, thank God. Thank God, you know? I mean,
we're we're pushing really big with women in technology as well, and trying to get women involved in the semiconductor industry because it is a male dominated industry. But I can tell you from experience, some of the most incredible people I've worked with were women, just knowledgeable and just incredible learners. We're women in the industry, but there's just not enough, and so we have to see more women going into engineering and technology, and that's a big push for the industry as well.
yeah, yeah, absolutely. Well, and those jobs will be there, right? They're moving the fabs back. I mean, yeah, the demand will only keep growing, you know? I mean, everything now, you mentioned the Internet of Things, right? Everything
Mhm.
has microprocessors, everything has chips going into it, not just microprocessors. I mean, you've got graphics cards, timing cards, clocks, I mean, the list goes on, and all of these need to be designed and redesigned and updated, even things like, I would imagine things like bus speed changes probably require, at the very least, they probably require recertification for chips, you know. So yeah,
Definitely.
it's
Yeah.
it's amazing. Well, Robert, thank
It is.
you so much for your time today. Thank you for joining me. I can't
Yeah.
thank you enough. It's really exciting. Again, I'm going to put your links in there. So let me ask, what comes up? Let me close by asking, what comes up for you in the short term? What are you looking at in the very near future here?
Near future. Um, Gosh, we have so many things going on. Obviously, I'm involved with SEMU as well. I call SEMU my side job, and my full time job is working with MOOV. MOOV is just expanding incredibly right now. MOOV is a managed marketplace for used semiconductor equipment. The
Mm,
uh, used equipment industry is exploding in growth, and the equipment is becoming harder and harder to find. And so MOOV has created a platform with 19,000 listings and $3 billion of inventory, so people can go and search for the equipment that they need, and be able to make those matches MOOV makes those matches happen between buyers and sellers. But so that's my full-time job, is working with MOOV, and then of course my LinkedIn, where I'm just posting all day and writing about the semiconductor industry and talking about what's going on. I think my LinkedIn now is something like 8 million
yeah,
impressions,
yeah.
and
It's tremendous.
36,000 followers. It's incredible. And I just get more and more messages every day from people saying that they just love the content and love reading, all the information that we're putting out. But I guess with the biggest thing that I just came back from was Semicon Europa. That was huge, and I had really a lot of fun flying to Munich and meeting with everybody in the industry in Europe, and seeing everybody again. And I guess next thing we have coming up is GSA has a big event coming in December, and I think there's also uh, Semicon West coming up as well. So those are big events for the semiconductor industry, and they'll definitely be consuming a lot of my time. But
Wonderful, wonderful. Robert, thank you again, sir.
It was great talking to you, Tim. Thanks so much.